So I will just start with an outline before diving into the details. I'll start with the background and the computational tools that we have and the vision for using them, then talk a bit about the story of how we started with the in-house basic training, then stop for a second to talk about very nice examples with reaction kinetics modeling and how we leverage that actually to get into a global tour, which I call, to do advanced training in TEVA API. I'm going to then move to some success stories, which I usually combine in those trainings, and then wrap up about simulations and go into the human model, which is, for me, the best and the most important one, of course, and of course end up with some concluding notes. So if I go into the first chapter, so the background is probably well known to all of you. Our industry is comprised out of a sequence of, let me just wait for the presentation, oh great, of synthetic organic chemistry processes, which are usually a set of unit operations such as reaction and distillation. And in the beginning of R&D, we start by screening and optimization of parameters for a process, and later on we want to scale up and do a tech transfer to a production site where we, well, produce. And once we are in this industrial scale, we are closely monitoring everything by usual control, offline analytics, batch cards, and have regularly being audited by either the FDA externally or, and of course, also internally, which is very important in our industry. Overall, if you look at how many considerations we have, it's almost too many. Yield, chemical quality, safety, of course, operational, market needs, patents, QA, and so on and so forth. So we have quite a big deal on our hands. And what I would like to do now is just to talk a bit about the basket of tools that we have in TAPI R&D, which we want to use to enhance the R&D project, to adopt new technologies, and to, of course, support always production. So the first group would be DOE, where in statistical approach in tools like JMP and MODI and Design Expert, we want to minimize the amount of experiments and to get the most of information out of them, to screen out parameters, get the CPPs out, and do maybe a bit of optimization. And then we have mechanistic model-based process simulations, such as Dynochem, which has a lot of tools, reaction, crystallization, heat and mass transport, which should reflect our true comprehensive understanding of the process. And of course, we have dedicated tools for mixing like Visimix and ChemCAD or AspenTech when we go to unit operation, for instance, when you want to actually design a distillation column for solvent recovery. And we end up with naturally big data analysis or just data analysis, where we can use MATLAB, for instance, to actually program codes to process data, visualize, analyze, and even create some graphical user interface that would be GUI supported applications that we can export to different users. And once the data is structured, we can choose to use it either in MATLAB for analysis or in the more standard tools like JMP and MODI. Impact. I'm very proud to tell that we have more than doubled since the end of 2014 the number of our users. We have more than 250 right now, 250. We had more than 1,000 entries in Q1 2016. More than 1,000 hours recorded in March. By the way, in our last month, even more than that. It's not in the plot that I'm going to show you in a second. We have an average used of more than 5 or 6 times than we used to have in the past 2 years before I joined, and I'm very proud of that. And this is excluding standalone licenses for our heaviest power users. So the numbers I'm going to show you in a minute are even better than what I'm going to show. And we have more than doubled our number of power users in the community, and now we have at least one in each site. So this is really good. And looking at that, those numbers of monitored use, again, countries here separated by different colors, and this is excluding, again, our heaviest power users who have separate non-monitored licenses. So when we just began the training, we already have an effect, and we had about 300 hours of average monthly use, and now we have something like 700. So the impact is very clear, and it's very easy and important to show that to the management, besides reports of success stories, of course. So first and foremost, to Amir Gold, my predecessor, we started this together with my boss, Guy Samburski, who always helped me and still is. They initiated that in TAPI, and I had a wonderful legacy to start from. For TAPI management at all levels, their trust, leadership, their support and backup was always and is always a big help, and it's wonderful to work with them. For TAPI Global IT, Adas and Moshe, if you are hearing this, your outstanding support and commitment is nothing to be taken for granted. I'm lucky to have you with me on board. For the TAPI Power User community, I think I've spoken just a bit about you, but your help during training, your ideas, your wonderful spirit, I'm just honored to work with you. So Franio, Yossi, Orel, Laszlo, Levente, Iri, Mina, Maurizio, Claude, and the new members, thank you again for being so wonderful. And last but not least, the Dynochem team, Joe, Steve C., Steve H., Andrew, and Wilfred. Your kind support, your help in way more than temporary licenses, your encouragement and the outstanding expert training that you give. This is a wonderful experience for me, so thank you again. And just to end up, that I really am thankful for being able to have a true love for teaching, because going around the world to so many places and really preaching here to use and to do different things, you gotta love teaching, and I'm thankful to really love that. So this is a big issue for me. So as well as today, thank you for that, and thank you all for listening. I'd be more than happy to take questions now.